So now we're going to see how we can run a hypothesis test using the t-distribution in the calculator, where we should pay close attention to what we're being asked to find. Here we have one of those rare cases where our claim lands in the null, as we are starting from the claim that the mean price is at least 21,000. There we have an equality in that claim, so it is in the null. But for us, the big things we should pay attention to here are that we're given a sample of 14 used cars that had a mean price of $19,189 and a standard deviation of 2950, where we are going to test this claim for level of significance alpha equals 5%, where we know we're using the t-distribution for this because we are only told information about the sample. We're only given a sample mean, and that 2950 is specifically the standard deviation for those 14 cars. That is an S value, not a sigma. So when we're going to be testing these hypotheses, we are going to test them using the t-distribution because we do not know the population standard deviation. And from here, if we want to do this by hand, getting that t-score and our values here, we can, where this will give us our test statistic. And if we want to get the probability associated to that test statistic, we can, but it's a little bit more efficient to use the t-test computation directly instead, where what we're going to do is go in here. We have statistics. In this case, I'm going to scroll back up to make sure I have all of them properly, where the mean that we are testing is 21,000. The mean of our sample is 19,189. The standard deviation is 2950. And our sample size here is 14, where when we make this determination about mu not equals less than greater than, that's in terms of our alternative. We're here, we're looking for a left tail, we are looking for less than. And if we want to see this, you can see that we get, up to rounding, the appropriate t-score. And then if we want to find the p-value, we can use the tcdf function. It's very rarely seen, but really we're better served going with this t-test computation. In any case, we get the appropriate values here, where we have that the p-value is less than alpha in this case, or if we want to be sure, we can also get the critical value here, where because we are looking for a t-score associated to 5% in the left tail, that level of significance 5% down there, and we have 13 degrees of freedom, that would end up giving us a critical value of -1.77 approximately, where because our t-score is less than the critical value and we are using a left tail, it is in the rejection region, and therefore we have enough evidence to reject the null hypothesis. In this case, that means rejecting the claim. Next, for our more fun example, we can take this data set that we have here in these obviously not made up supercomputer responses and go into our list editor and plug them in like so. I already put them in there to save us a little bit of time, but you put those in yourself. Once those are into your list, you're going to hit stat again, go to tests, and we're going to run the t-test. But here we're not going to run the t-test on the data set, where our mean that we're comparing with is 42. We're running on list 1, and we are testing for any difference. We're just testing to see if the mean is different from 42, where if we want to do this, we just have to make sure we highlight that value, select that value, important thing to do, and then we calculate. Where seeing this, we get a t-value of negative 2.89 and a p-value of about 0.015, where, because we were running this test at the pretty standard level of significance alpha equals 5%, we have that the p-value is less than alpha, and because the p-value is less than alpha, we reject the null hypothesis. Now, if we want to do this to be sure, we can also call upon the inverse t function again, where here we have to remind ourselves of how many degrees of freedom we have. Because we got 12 values, we will have 11 degrees of freedom. And in this case, for our area, even though it's still 5% like last time, we're taking that 5% and we're splitting it equally between the two tails. So on the lower end or the upper end, whichever we want to use, we have to be sure that we're only taking 2.5% now, which would give a t-score of negative 2.20 approximately, which, as we saw, is bigger than our t-score in this case. So, appropriately, our t-value is within the rejection region, and for very similar reasons, we will reject the null hypothesis. So just to be sure, here's one example where we are only going to look at it in terms of critical values, where we have this pH level, where we're given that they are claiming it is 6.8. So again, another rare one where the claim is the null, but that does happen. And we are selecting 39 for a random sample with a mean of 6.7 and a standard deviation of 0.35. And we want to check the claim at a level of significance, yet again, of 5%. I swear you're going to see problems where it's not 5%, but it is the most traditional value. So for this, stat, tests, t-test, and we're going to see what happens here first, just so we know what we're going to be comparing with, because we've got all our numbers. So the mean we're comparing to is 6.8. The value x bar that we got from our sample is 6.7, which is very close, and our standard deviation is 0.35. So you should notice that even though they're very close just empirically, there's not a whole lot of variation in here. So it might make sense that they look like they should be near each other, but they might not be near enough. We'll have to see based on our test. Where here, we are testing for anything other than equality. So we select the two-tailed not equals option for our alternative. And when we run this, we get a t-score of negative 1.78, along with a p-value of 0.08. So again, it's pretty quick to check the p-value if you've got those pieces, but for the sake of completeness, we're going to run this with the t-score as well, the critical value approach. So for that, we go into our inverse t function again, where we are looking for 5% in either tail. So we split it up, and we can take either side. I'm going to take the smaller one because it looks like we were moving to the left. Here we'll have 38 degrees of freedom, and as a result, we are going to get that our critical values, in this case, not just the one, are negative 2.02 and positive 2.02. But importantly, the t-score that we got here is in the middle. Generally, it's a little subtle to tell, because sometimes, we want to see if it's bigger, if it's in the right, or if it's smaller, if it's in the left. So it's easy to lose track of that. But for the two-tailed test, I think it's a bit easier than either one tail to identify if it's in the rejection region or not. In this case, it isn't, because specifically it lands between the two tails. So in terms of the same sort of thing we saw with the p-value, because this is not unusual enough, we fail to reject the null hypothesis in this case.